Good morning. Myself Chandana. I'm second year student in Computer Science and Department in Srinivasa Ramanjan Institute of Technology. So, today I want to tell about directory implementation in operating system. Directory implementation in operating system can be done using single linked list and hash tables. The efficiency, reliability and performance of a file system are greatly affected by the system of directory allocation and directory management algorithms. There are numerous ways in which the directories can be implemented, but we need to choose an appropriate directory implementation algorithm that enhance the performance of the system. Let's see directory implementation using single list. The implementation of directories using a single linked list is easy to program but is time consisting to execute. Here, we implement a directory by using a linear list of file names with a pointer to the data block. Let's see. This is the directory implementation using single list. So, this is the first element. The first element is inserted in the array. So we have a pointer here. We have a pointer here with data block. With data block. So it keeps data. The directory of the file name and the pointer, the information will stores in the storage memory. So this is a linked list. So here we have another pointer. This pointer points to the other element in the array list and it is connected with the node. So file name 2 is the other element and we have the pointer, again we have the pointer here with the data block. So if we want to add other element here, same we have the pointer again and this is a file. Let us think this is the file name 3 and we have a pointer and we have a null here. So like this a linked list will goes on. So to create a new file, the entire list has to be checked such that the new directory does not exist previously. So if you want to add a directory in a list or either end or either the beginning. So first we have to check whether a new directory is exist in the previous list or not. Now if we want to delete a file, first we have to search a directory file name. After searching the directory name, then we can delete that file and we can give a space to that. So to ensure this entire directory, we can mark the entry as unused or we can append it to the list of free directions. So to delete a file linked list is the best choice as it takes less time. Disadvantage or the main disadvantage of using a linked list is that when the user needs to find a file, the user has to do a linear search. In today's world, directory information is used quite frequently and linked list implementation results in slow access to a file. So, the operating system maintains a cache to store the most recently used directory information. Let's see an example. Now here we have a one linked list and this is connected with another linked list. So this is connected with the other linked list. So like that we have so many linked lists. So we have like n, so n linked list we have. So now we want to search a, so now we want to search element here. So we want a element from here. So for that first we have to search element here and again we have to search element here and again we had to search element here. Like that we had to goes on, we had to check every element and we had to search for every node. At last we can find the element here. So this is the main drawback by using a linear search. So directory implementation using hash table. An alternate data structure that can be used for directory implementation is a hash table. It overcomes the major drawbacks of directory implementation using a linked list. In this method, we use a hash table along with the linked list. Here, the linked list stores the directory entries, but a hash data structure is used in the combination with the linked list. In the hash table, for each page in the directory key value pair is generated. The hash function on the file name determines the key and this key points to the corresponding file stored in the directory. This method efficiency decreases the directory search time as the entire list will not be searched on every operation. So this is the hash table. So this is the hash table. So we want the element here. So we directly goes here. So we escape this first element. So if we want to another element here, for example we want the element here, so we'll escape this element and directly will go here. So like this a hash table will goes on. For hash table also we have a drawback. The major drawback of using the hash table is that generally it has a fixed size and it is dependency on size. But this method is usually faster than a linear search through an entire directory using a linked list. Let us see an example. See, we have 64 entries. In a hash table, we have total 64 entries and the hash function converts ranges from 0 to 63 for 64 entries. Now we want to create a 65th file. So for that, the hash table enlarge the directory to 128 entries, means 64 entries to it enlarges 128 entries. Now if the directory enlarges, then the hash function automatically change the range from 0 to 127. First it has 0 to 63 range for 64 entries. Now for 128 entries the range changes from 0 to 127 and it recognizes the existing directory entries and it reflects the new hash functions. Thank you.